Again, the agenda. So app-based policy phase 2. So this is an enhancement to the application-based policy feature, which was introduced in AOS-CX 10.12 that provides 3 additional actions that can be applied to classified application flows. The first is you can remark app flow packets to a specific diff-serve code point value. You can change the local priority value for those packets if you're using layer 2 QoS. And you can mirror those packets to a specified mirror session. So this basically allows you to redirect to mirror application flow packets if you desire additional monitoring of certain applications on your network to monitor for suspicious or unexpected behavior, or to use in troubleshooting network performance issues. For the priority remapping options, this is a great way to dynamically optimize the performance of specific applications, say voice or video streaming or communications across the network, to prioritize those specific applications without necessarily applying blanket QoS policies to all traffic utilizing certain ports. So if you only wish certain types of applications or specific applications themselves to optimize their performance, this new feature allows you to do that on the fly using the app classification system. For more details on application-based policy as a whole, I encourage you to review the AOS-CX 10.12 application-based policy update, and I have linked to the YouTube video where that has been posted here. So let's get into some details. We'll start with platform support. Because this is based on the application recognition and flow tracking feature as dependencies, the platform support that applies to IP Flow Manager also applies to application-based policy. So we support all 6300F, 6300M models, both standalone and VSF stacks, as well as 6400 systems with V2 line cards installed and using a V2 system profile. So the first new feature is the ability to remark flow packets with a specified DSCP code point or a predefined class. So we have predefined 12 assured forwarding class values, class 1, class 2, class 3, and class 4, with low, medium, and high drop probability per class. We also have 8 class selector values from 0 to 7, or you can actually specify a particular DSCP code point value from 0 to 63 if none of the predefined options are implemented or desired for your particular setup. The second new action is local priority remarking. So this lets you remark packets with one of the 8 predefined local priority values, 0 to 7. Each one of those local priority values is mapped to a specific queue on the switch, and that will vary depending on the queue profile that that switch or stack is operating on. So I have an example of the factory default queue profile on the a 6410 V2 switch. So you can see we have 4 queues by default, and we have 2 local priorities mapped to each queue from 0 to 3. So we have basically 0 and 1 go to queue 0, 2 and 3 go to queue 1, 4 and 5 go to queue 2, and 6 and 7 go to queue 3. The final new action that you can apply to application flows in app-based policy phase 2 is mirroring. So this lets you mirror those matched flow packets to a mirroring session. Now in AOS-CX 10.13, you are required to use mirror session 4 for packets being mirrored by app-based policy. You can use any supported mirroring destination from session 4. So you can mirror to the switch CPU, you can mirror to a specific interface, or you can mirror to a tunnel destination. Now it's worth noting that if you are using the mirror action and another action at the same time, such as remarking DSCP or local priority, that local priority or DSCP remarking does not take place until that packet leaves the interface and is in transit to the egress. So that remarking will not be reflected in the packets that are mirrored using this action. So if you wish to observe the remark packets, then you will have to mirror traffic from the egress interface on the switch to capture those and validate that those packets are being remarked as expected. And I'll show what that looks like here during the demo in a bit. So how do you deploy these new actions in app-based policy phase 2? We'll start with the local user role configuration. So you're going to, just the same as you would for any other app-based policy, you're going to create or modify an existing policy. And as part of that numbered sequence of policy attributes that you're defining, you're going to assign the desired actions to those classes. Those include drop, which was part of the original app-based policy implementation. The new actions are DSCP, local priority, or mirror. So if you look at the examples I have here, the first two classes are applying a DSCP remarking to assured forwarding 11 and mirroring those packets to mirror session 4. The next two classes, 30 and 40, are only mirroring those packets to mirror session 4, and the remaining two classes are simply permitting those packets to pass without additional action. And then once that policy has been created, use the show port access ABP command to verify that the policy looks implemented as intended. To configure downloadable user roles using the new actions, you're going to create or modify that enforcement profile in ClearPass. And in the downloadable user role attribute, you're going to define that policy with those new actions, just as you would any other app-based policy in for a switch that's running AOS-CX 10.12. It's worth noting that you want to make sure that any switches that are utilizing an app-based policy with the new actions, they must be running AOS-CX 10.13 or later. If you try to apply an app-based or a downloadable user role containing a policy with actions that are not supported in an earlier version of AOS-CX, in this case 10.12, then that policy will not be processed correctly and will not be applied to those switches running those older versions. So with that, I'm going to show a quick demo of what app-based policy phase 2 looks like. So let's go ahead, jump over to my other display. So I'm going to start out with I'm using downloadable user roles to apply my app-based policy. So I have an ABP downloadable user role here. Go ahead and open that up. And if we take a look at the content of the downloadable role attribute, you can see I have 6 traffic classes. I have a class that matches any unified communication app as well as Microsoft Teams for both IPv4 and IPv6. I have a class that matches any video streaming app such as YouTube, YouTube TV, as well as the Twitch website for both v4 and v6. And then I have 2 catch-all categories that will simply permit any other traffic that doesn't match these 4 classes above. So any other application or any unidentified application will match one of these 2 classes and will simply be allowed to pass. Then I have the app-based policy itself. So I can see these first 2 class matches. I am remarking those packets with assured forwarding 11. The next 2 classes for streaming apps, I am mirroring that traffic to mirror session 4. And then I have my catch-all classes, which are simply being allowed to permit. And then I have the remainder of the port access role configuration here at the bottom. So I have a client that is connected to this switch. So if I go ahead and show my port access client information for port 131, I can see I have an authenticated client here, see the VLAN details, MAC authenticated. and I get my role information. So I could see my app-based policy downloadable user role is applied, app recognition is enabled. I have an app-based policy that is applied for this user, and I can see the app-based policy details here where I can see the sequence as it should be based on the policy that was downloaded to the switch when this user authenticated, and then I have my class details here. Everything looks good. So let me go ahead. I have my client here on the left. So this is the authenticated client for which I am mapping my app-based policy to. And on the right-hand side here, I have a packet capture station that I'm going to use to verify that my app-based policy is working as expected. So I'm going to go ahead and start my capture. This is the IP address of the client, so I want to make sure that the only traffic I'm seeing is traffic from this specific client. Go ahead, open up a web browser session. Now, if you remember from the class, the policy that I defined, I'm going to start by verifying that my mirroring is working as expected. Let's go to my clients. I'm going to try to open a few websites, and I want you to watch the capture station here on the right. So let's go ahead and open up the Aruba Networks website. See, not seeing anything here on the right. Open up the HPE website. Again, no traffic here on the right. Now I have bookmarks to two different streaming services here, YouTube and Twitch. You see, as I hover over these and the browser pings those websites for, say, updates to the fave icons here, we could see those initial connections being established and then immediately broken down here. But if I open up the YouTube website, here we can see immediately, we see a whole bunch of packets being transferred here. So we are seeing that traffic being mirrored here because app recognition has classified this connection as being to the YouTube streaming service. If I do the same thing for Twitch here, we see it is capturing those packets as that website is loading as well. But if we go back to another website here, nothing. So app-based policy is mirroring only the traffic that we've specified to be mirrored to that mirroring session based on that app classification. Let's go ahead and close that browser session. Now I'm going to go ahead and clear this because I'm going to switch to the next part of the demo, which is DSCP remarking. So let's go ahead. Go to my terminal here. So I'm going to stop mirror session 4, and I have a second mirror session configured that is monitoring the uplinks of this switch, so that we'll be able to see the remarked packets with the DSCP value that we've defined in the app-based policy up here. So we expect to see AF11 for an application that is utilizing, that is matching one of those classes. So I have an application that is using one of those classes, and we can actually see, a lot of traffic here because we are now monitoring the uplinks of this, this connection. Go ahead and clear this one more time to clean this up a bit. And I'm going to join a meeting using Microsoft Teams. Now, what we expect to see here, if we look at the packet headers here, we should be able to see DSCP values that are being remarked for this application. So if I go ahead and hit join, we should see a burst of traffic here. I'm going to stop this to let me take a look here. Find one of the application, find one of the packets for that initial flow here. Oh, let's try that again. Let's restart that. Go ahead and join. And then leave. Oh, there's a lot of traffic, so let's go ahead and there we go. So we can see one of the packets for this packet flow. The traffic coming in, this is actually the mirroring header here. But if we look at one of the traffics that is part of this flow here, we can actually see that AF11 DSCP value as those packets are being remarked. And if we see other traffic here on the switch that is not being remarked, and then we can see other application, we can see other packets that are part of that application flow, that traffic is being remarked as AF11. So that's DSCP remarking, and that is a demo of some of the new features in App-Based Policy Phase 2. Some additional resources for App-Based Policy Phase 2 and App-Based Policy in general. You have the AOS-CX 10.13 Security Guide, Chapter 16, Application Recognition and Control. The AOS-CX 10.13 Monitoring Guide, which covers the mirroring feature. So this is for your general mirroring sessions, for setting up your mirroring sessions, tunneling destinations, and any restrictions based on other features that you're running at the same time. And then you have the AOS-CX 10.13 QoS guide for general guidelines on configuring quality of service throughout your network, including CX switches.